Hey guys, Albert here, checking out a new game called While True, Learn, which is a puzzle game that requires quite a bit of logic, and I am hoping that we can have some fun with it. We are going to start a new game here. I have played this already because I was nervous about just sitting here on recording going, I don't know, where does it go? But we will start with the tutorial anyway, and let's come up with a name here. Let's say we're Game Boy. You know what? No. Game Man! Hello, friend. Welcome to our game. This is a tycoon game that will give you an opportunity to take the role of a machine learning specialist and evolve from a rookie to professional. We hope that our game will help you understand machine learning better. Oh, it's educational? Well, that's disappointing. Spanish school at cat.meow. School problems. Good morning. We are running a big social survey in schools and we've encountered a problem. Our students often forget to mention their grade in the questionnaire. Can you divide pupils? No, I'm actually going to go with pupils. From junior and high school based on their test sheets. Accept job. And then they have these little things about the history of machine learning. Expert system. In-game. This node compares colors. If the color of the element is equal to the chosen color, the element comes into the top socket. Right there. Others go out the bottom socket. In the real world, before the invention of self-learning algorithms, people used expert systems. These algorithms tried to use hard-coded comparisons similar to human experts' decisions. It worked terribly. So, this is how it goes. We drag our little block elements out from here. We have our inputs from over here. Currently, we only have one. And we want to sort between the red blocks and the blue blocks. We have 10 reds and 10 blues. And our expert system allows us to pick a color. Now, they've already set it on red, but just for the sake of making things a little more interesting, we're going to dive in. And so you can see here what we've done. It looks at the block. If it is blue, it sends it down here. If it is red, it sends it down here. Else means not blue. If it was another color, such as green, which also exists in this game, it would also send it down here. We'll get into that in a little bit. We're going to run our tests pretty fast because we're impatient. Success! And we're going to release our program. And then there's this warning about renting servers, which is not really a big deal. There's a money component to this game. Like, for instance, we've earned some money here, I think. We spent $42. Yeah, here we go. $258, cat bucks, whatever they are. We got 300, but then we had to spend some on the cat cloud. And here is our information about the task tree. The task tree displays your in-game progress. You will be receiving different types of tasks. They will be marked with different colors and icons. Each icon corresponds to a certain type of task. As you get further in the game, more awesome stuff will start appearing in the in-game shop. Lines on the task tree show in which order the tasks will be unlocked. If you see a task which is locked at the moment, you can check its requirements by placing the cursor on it. Sometimes in order to unlock a task, you will need to complete a certain group of tasks or even several groups of tasks. And then they talk about the tree structure. Up and down is sort of the main story, and then there's side quests on the side, like you would expect. We already did school problems, and we're going to move on to applicants. Good day! You have coped with the previous task so well that we decided to entrust you with another one. Summer exams have passed here already. The exam results are attached to the letter. Could you predict which of the students will be able to get into MIT? None of them, because your school sucks. And this talks about how the requirements to successfully complete the task. There's the amount of data, also known as occupancy in the readout. And then there's accuracy, which in these early tests will all be 100. We will have to complete these perfectly, but eventually it will become less than 100, and that'll be fun and tricky. So once again, we have our sorting number. We have our green and our blue, so we went to change to blue. Actually, for the sake of simplicity, we'll go up to green. And then we'll have blue come down here. And we're not even... We're so confident that this is going to work, we're not even going to do a test run. That's going straight out to release. Baby. Don't even need to debug this code. That's how much of a boss I am. Machine learning expert Albert Berg. Yeah, $300. $300 error. Hello, we've come across some errors in our questionnaire data. We can't solve the problem by ourselves. Can you fix it? Here's a fun little tip, by the way. None of these emails actually matter to the task. Many different types of metals on many levels. By switching between those metals, you'll be able to see the additional conditions and restrictions imposed on this task. Oh, be able to see additional restrictions. So, if you want to level up, you'll receive additional earnings by doing the harder one. Do your best to receive the medal you wish to get right away, because even though you're able to complete the task, recomplete the task and obtain a better medal, no financial bonus will be given to you in this case. And there's the trash can, which destroys stuff if you didn't know what trash cans do. In the real world, real data sets have lots of errors. Filtering out errors is a very important skill for all data scientists. Alright, so we can click on there and we're going to be on the top level here. Now, you can see over here we have red, green, and blue. And over here they want red and green. We will solve this problem by filtering out blue, sending that to the garbage, and everything else goes over here. We of course need our input attached. And once again, we're so incredibly confident in our abilities that we're not even going to run a test. Because, you know, the tutorial's easy mode. I will add, having played this game somewhat, the main tree tends to be relatively easy mode. It's only as you get, like, in the side quests that things really start to get hairy. Hello, it's us again! We've found some new types of errors made by our users. Please update your program. It will be easier if you use a previous version of the code. And here we are in the tutorial. Yes, I know about game speed. I'm already using that. Thank you so much. So here is something that they're going to teach us about, which is custom nodes. So we're going to use previously constructed programs. It says you can use programs that you've constructed while completing previous tasks. Here you can see all the schemes made of basic nodes recursively, which are allowed to be used for this task. Custom nodes don't waste time on transferring data from one node to another. At any time, you can get back to the previous tasks and rewrite the programs. For example, you may want to optimize them better to fit your current task. Click 2 times RMB. Oh, that's the... Yeah, okay, that's the right mouse button. On the custom node to jump directly to the scheme. And then it also talks about the acceptance frequency. This icon displays how often the custom node receive data for processing. It's essentially how fast they can do what they need to do. And this displays the total amount of processed elements at the current moment. So that's that up there. Now, we used the or-else divide already. They want us to go ahead and do that again. So since we have or-else, despite the fact that it actually isn't faster than to just go ahead and use the red thing like we did before, we are going to go ahead and do that because that's what the tutorial really wants us to do. And I have to get the trash can. There we go. Once again, no scope in this bad boy. No! We did it wrong. Stop! The no scope didn't work. Or else. Oh, guys? Guys, I figured it out. I figured out what the problem was. That's embarrassing. Oh, I went to the wrong one. I'm sorry. Okay. I've actually... No! RL should work. Oh! Guys? You know what happened? Because I was so incredibly cocky about what I was going to do, and I was like, hey, I'm going to show y'all something new. I changed it from what it was, and they didn't stop me. And I went to use the previously saved thing for RLs, and it did not work the way it should have. Albert is embarrassed. Let's try this again. Let's do a test run, guys. Hey, that's working exactly like it should. Because I didn't change it initially. We can go ahead and release it. Wow, my incredible cockiness came back to bite me. It's a good thing that's never happened to me before. Otherwise, it would be real embarrassing. Making that money. Alright, and here we are out of the tutorial. Hey, it's us again. We hope it's our last request for you. We've changed our database system. Can you update your code one last time? We need it to work faster. I said we're out of tutorial, but they're still teaching us stuff. This node compares sockets colors with elements colors and chooses the socket with a minimum amount of errors. If the element color is equal to only one socket's color, then the element moves to that socket. If the element's color satisfies both conditions or doesn't satisfy any conditions, then it moves to the random socket. What that means is, let's say we use this, and we want to send reds and greens through. So red, greens, and blues will all come through here. Now let's say I pick blue here, and it sends blues in. When a blue comes in, it'll go through the blue notch and go down this way to my garbage, because we only want red. However, and if a red goes in, it'll go through the top notch and go to red. If a green goes in, though, it will randomly pick one of these two and go through that. So we have to add in yet another condition here and say, hey, we only want red. Which raises the question why we would use this at all. And the answer is because of time. Because this happens faster at 0.3 seconds than this does. Which means that if we were to just run it with the red else system, it would not work properly. In fact, let's show that here real quick so you don't think I'm just blowing smoke up y'all's butts. Let's do a little testy test. Say, oh, we're going to be smart. We're not going to do it like you guys want us to do it with the new thing. We're going to do it with the old thing. I've tricked you, tutorial. But no, we ran out of time, see? So we have to delete that. Let's bring that in. Now, I think, actually, that there's going to be... If we put this in here, we can do it that way. But I'm going to try it a different way. See, what we're going to have here is reds and blues getting sorted, but greens getting randomly sent out. So the greens that come through here, they're going to be fine going in the trash can. The greens that come through here, well, we don't want those because we want only reds in this box. And so what we can do is use a couple of these in tandem to sort out the greens. Let's see if that works quickly enough for us. Oh yeah, that just flew on by. We can release that real easy. And we're going to say don't show this next time because so far it hasn't been a problem for me, and I've played fairly far into the game. Far enough to really, really hate the background music that's just doon 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 over and over and over again. Yeah. Do we have any money we can spend on, like, eBay? For instance, everything seems to be locked. All of our hardware seems to be locked, which is normal because, you know, we haven't got very far. We can buy a little cactus. Yep. Hide in room. Why would we hide it? We got our cactus right up there. Okay. We can buy a different cat if we want to, but let's go back into our tree. Now, we're going to do a side quest here. Good afternoon. We are a cargo transportation company and are now working passionately on improving our service. Think it should have been improving. I can't tell if there's a joke there or not, or if it's just, like, bad copy editing on this game. Our cargo distribution system is old and works badly. It often fails. We want you to automate the process and make an algorithm which will sort the goods by their characteristics. This is very crucial for the efficiency of our delivery. High sorting accuracy is very important to us. Do you accept the task? No, I run away screaming like a little girl. Yes, I accept the task. Okay, so this is interesting. What are we going to do here? So we have red here and here. We're going to want to split those in half. That seems like... Okay. Now we have green. That is also... We have red and green, and then green and blue. And there's an occupancy requirement for this slot. Now the occupancy requirement, I think, can be met just with the blue. So let's not worry too much about that. Let's say we want this. Now reds will always go... Well, let's say... So blues will go down here. Blue always goes down here. That's fine. Some greens will also go down here. A random number of greens. Actually, I'm not 100% sure that it's actually random. I think it might be also possibly a little bit 50-50. But what we're going to do now is take our reds, which will have some greens in them. And since we want more greens up, there's a higher occupancy rating on this one than this one. I think we're going to send greens up there, and then we're going to have a blue for this one, which will send a random number of reds to either. Let's see if that works. It looks like we might run out of time before the bottom fills up. No, we did it. We got it. Our test run is complete, and our estimated result is this. Can we get a gold? Oh, we have too many nodes. How do we have too many nodes? We only have 2. There's not 3 nodes. I'm tripping here. I guess these count for 1.5 nodes. Interesting. So to get the gold, let's see if we can use the or else divide. How many does that count? That counts for 1 of those. Now reds are going to go up here. And we're going to go back over here. And we're going to sort greens down to here. Because we have plenty to fill that up. And we're going to sort blues up this way. Now, we're still over the node limit, though. Jeez, that's not fair. Can I use the else? Yeah, that keeps us under. Or wait, no. This was good here. This was fine. Okay. Original plan left in action. Actually, I want the bottom one to be green and the top one to be blue. And here we go. Let's see if that works us. Come on, gold medal, baby. Gold medal, gold medal, gold medal. This is clearly working way slower than the other one did. No! Okay. I think I have an answer here. It might be the answer that I already had, actually. I may have been misreading this thing. So we have greens and reds coming through here, which is fine for that. And hopefully will produce enough of the occupancy level. We have blues and reds going through here and then getting split into blues, which will go here, and reds, which will go here. And we are going to test run this bad boy and see how we did. Yes! I don't know why it's estimated. Oh, the time is too high. I give up. I give up on trying to get the gold level on this. The gold medal. Gold medal's not gonna happen, y'all. Silver medal's not gonna happen. We are happy with bronze. Illuminati origins. Good day. I study ancient manuscripts and books in order to figure out the true story behind the Illuminati secret society. I need to recognize all the triangle shapes in these documents to solve the puzzle. Could you design a program that would do that for me? Sure, dude. This block compares shapes. If the shape of an element matches the designated shape, the element goes to the top socket. The rest go to the bottom socket. In the real world, SIFT, Scale Invariant Feature Transforms, is one of the most powerful non-neural image recognizing algorithms. It should be... Man, they should have had a grammar recognizing algorithm for this game. SIFT is very fast and capable of recognizing simple objects and patterns. So this is taking us back to baby school, like the original thing, only with shapes instead of colors. So we want to have a triangle over here, and everything else down here. I want to no-scope it and just release, but I'm going to run the test because, yeah, it's bit me in the past when I didn't run the test. Yes, okay, now let's watch the exact same thing happen again! Thrill and amusement and amazement as you learn about machine learning! Surely we could program a machine to learn about this for us, huh? You'd think the guys who made this program could just program a machine to learn about machine learning. Badumts! Alright, chicken escape farm. Hi there, my name is Sarah. I own a small technology farm. We are improving our process using the latest technology. Those are sentences and words that I read. Shops we are working with need supplies of eggs of different kinds, and it takes a lot of time to sort them manually. That's why we've decided to automatize the process? Okay. We have all the necessary characteristics used to calculate eggs parameters, but we need an algorithm which will work without any human assistance with high accuracy. You know, they make machines to do this. Like, before computers were even a thing, we had machines for this. Okay, so, here's what we're going to do. This is real easy. Circles going up here. Down here, everything else that's not a circle is going to get sorted into squares and not squares. And that should be it. I don't know why they gave us the trash can. We got a silver medal on that, and I'm not smart enough to figure out how I would have possibly gotten the gold. I don't think I can get 100% accuracy with any fewer than these elements going any faster than this. So that's a real tricksy thing. I could add a trash can somewhere in here, but that would just mean that, like, we would only have circles and then trash. So we're gonna go ahead and release that. Some real smart person who knows the gold medal answer to this, let me know. Or maybe it's just sort of the whims of the RNG based on which things you get first. That must be it. He said after he got exactly the same result, running the same program the second time. Yes, we accept. Crowd psychology. Good day, our company is making a sociological research. Our company is making a sociological research. Well, maybe you should research the effect on poorly written sentences on the human brain. That's just a suggestion that I had. We are currently working in the field of quote-unquote crowd psychology, and we need an algorithm which will be capable of defining a person's type based on certain behavior triggers. I'm not sure you're real scientists. I don't think real scientists put their fields of study in quotes. This way we'll be able to quickly identify dangerous individuals in the crowd according to their behavior and prevent unpleasant accidents. What, like they poop in themselves or what? We have identified the parameters to work with, but we need an experienced developer to write the algorithm. Accept Yob. Okay. So what do we got here? Let's go with green. Let's go with green on the bottom. That makes the most sense. And blue on the top. Now, if we get a red, that'll just go through. Fortunately, let's see, we can get our trash can. We're going to be sifting through these kind of data. So, we don't want any circles down here. So, circles are going to go in the garbage. And up here, we don't want any triangles. So, triangles are going to go in the garbage. And then the else is going to go down here. They would have already been... Ooh, that's going to be tricky. We can use... Okay, we can use more sorting on this bottom one, because we're at 4 of 8 for a gold medal. So... red... Oh, this is going to be tricky. Interesting. So we're going to get red and green everything down here. We're going to throw away all the circles. Then we're going to sort what's left into red and green. We will take the red squares and send them along. And we will take the green triangles and send them along. And everything else will go in the garbage. Let's do a test run and see if that works. I think my logic is sound. The question is, will it be fast enough? We ran out of time. We were very close. We were super close. If we were using more of these decision trees, which only use 0.3 seconds, versus the sifts, which use 1.25, we could get a little bit more speed out of this. So let's try to figure out how to do that. I've just now realized this is redundant. This piece right here that sorts out circles doesn't need to be there. And I've deleted the wrong piece. That's fine though. We've got this. We're wanting... I actually will do green on the bottom because that's how it is in the thing, and red on the top. So we're already sorting out if it's a red and it's a square, it goes in, otherwise it goes to the garbage. If it's green and it's a triangle, it goes in, otherwise it goes to the garbage. There's no need to check if there's a square, and I think that will at least get us past. Might not get us a gold medal, but we should pass the test. You can see these guys overloading here as they're filling up with stuff to do and running out of time to do them. Still ran out of time, huh? Finally! Finally, we have success. I've been working on this problem for like 20 minutes. I cut all that out because that would be horribly boring to watch. But here's what I figured out. Okay, so we sort red and green, right? Blue can go either way. Blue goes up here, figures out we want blue squares and blue circles. We don't want blue triangles. So blue sorts for triangles. If it's a triangle, no, goes in the garbage can. Green goes down here, as does blue, and we sort once again to see if we want, because we don't want any blue coming this way. So we sort into green and blue, and that gives us our like definitive sorting. Blue then goes up to here. We're doubling up on this element. We might get a little more speed if we used a second one. In fact, I will go ahead and test that real quick. But we're gonna test for triangles here and then throw that in the garbage can. Let's see if that works as well. But that way we get this filled up faster. We kept having problems with occupancy because we were discarding the blues that we had. And now we're having trouble with... Oh, that's because we're stupid. We don't want the triangles, guys. We missed on accuracy. I think the principle was sound. We're sending triangles up here to get tested. Triangles all get trashed because there are no blue and green blue and red triangles. The blue and red circles get kept, and here we are with the silver medal. After 30 minutes, I will take that. We were going to release that and get our moolah. These side quests are where the game really gets hairy. I have, as you just witnessed, sort of, a difficult time completing them, but we're doing okay. Here we are. We got money spent. We got about $1,000. Let's see if we can buy anything on eBay. We can upgrade our hardware, increase sockets processing queues by 3. I don't know what that means. Or we can increase transfer speeds by 1%. Let's go with, I don't know, a couple of those. Whatever, hide. I don't want to hide in room. I don't know what that means. Yeah, let's go ahead and buy this too. Money, money. While we are here, since we've just finished really complicated stuff, for me anyway, let's check this out. These are startups, and this one's just from Geeks. Good day! We are inviting you to join our hacker startup. We write sheets and guides for different games, but we would like to create something very cool now. We need a program that will play and win in Arachnoid instead of the player. We know that you know a lot about machine learning, so we are inviting you to participate in our startup. And we can invest up to 1,200 cat bucks, which we have. So let's go ahead and do this. Now, the fun thing about the startups is that you can lose money. Now, they want us to build them. If your scheme contains self-learning nodes, you can disable learning in the test run. We're going to leave learning on. So, what do they want us to sort? Now, one of the fun things here is that speed is of the essence when you're dealing with these types of things. As a matter of fact, there's no reason to go ahead and use those. We can just use our custom node that sorts... I think we had one that was RBG. No? That's fine though. We can easily build this with the base node. So we're gonna do a red, 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 blue. This will go and sort out the greens because we don't want any greens. Greens will go in the garbage. And then this one will go and also sort out the greens into the garbage and send blues over here. Now, the important thing about these types of schemes is the speed, right? So they want 100% accuracy, but that we're actually going to have users. So there's a capacity that we'll have that if more users get on, this will get clogged up and we won't be making as much money. So you can see this just keeps refilling in the test run because all we're doing is... like, we're just emulating what it's going to be like under load. Let's go ahead and stop it and release our code. This deploys the code to the servers. This is a relatively simple one. I've seen these get real complex. But hopefully we'll make some moolah. And we can go back and tweak that anytime. Yeah, okay, so we have overload, and then there's account balance. And... let's see, there's 0% overload currently. Let's just click on day, and it'll advance to the next day so we can see how things are running. We have more users coming in and negative income. That's always good. Hopefully enough users will come in where our code will make us some money. Right now we're going to dive back into the tree. Now we're going to click up here. Alphabet recognition system. Good morning, Torvarsh. We know that someone from the USA created a system which can recognize the alphabet. You must create a copy of that system for the KGB. The handwriting of the USA spies is awful. Okay. We're working for Russia. So, here we are, and we're going to start introducing error rate into the game. Accuracy. We're going to get these perceptrons. It says, in the test run, perceptron reduces the amount of errors while trying to predict the shape of elements. In the deploy run, the perceptron only predicts shapes. And in the real world, Rosenblatt's perceptron used in the Mark I is this perceptron would only recognize simple linear dependencies, but it was enough to recognize English letters. So, we only need 40% accuracy here. And what we're going to do, this is sort of baby step one. We're going to run a training thing, which will just, you can see there's some errors happening, but the rate at which it's making mistakes is going down. And it won't go down really much below 20. We might get it a little, yeah, it'll bottom out at 20. Yeah, you can see it making a few extra mistakes, but I think we'll stop out at 20, and then we can release this. That's as good as it'll get, but it's plenty accurate enough for our clients who only want 40% accuracy, and we're well above that. Accuracy gets really tricky, and we'll see that, like for instance here, we have, they want circles and triangles up here, and squares and triangles down here. Which one wants more? This one. So you got to look at these occupancy requirements. This is 18 and this is 30. So we're just going to send all squares down here. Now, some squares will go up here. That's fine. But some triangles will also go up here. We're basically saying hopefully 75% of these will be in the right place, and it makes enough mistakes to make this work the way it should. Let's go ahead and run a training run. You can see our accuracy is not quite high enough. It might be. It's sort of hovering around, but the inaccuracy rate is going down. It went down to 20. So I think we can go ahead and release that. Even though there's technically no triangles going up here if this was a pure logic thing, the fact that it's only right 20% of the time means that you're going to get some squares up here even though you don't want them. You will get a few triangles, and we're sending our occupancy down so that the occupancy fills up correctly. Parallel calculations. Hello, we represent a scientific research center. Our current programs are underperforming. Can you parallelize our calculations? And then they have this thing that I don't care about. All your schemes use servers to process data. Some of the nodes require additional servers. The more servers you use, the more expensive your schemes cost. Let's go ahead and click okie dokie. Now this is again another sort of here's an element and here's how it works thing. This just splits things directly. I was going to say in half. It actually sends them to the node with the least load. But in this case, it's just going to split them in half. In fact, we're going to not even test run it. Because it's going to work. Because it's amazing. Alright, we lost 71 bucks on our startup. Yes, I understand how profit and loss works. So we had to spend money on the servers. We got 496. That's a negative. We're in the red. Let's check and see where we're at. Is there a way to improve this code? We're currently going relatively quickly. We're exporting at a little less than 3 seconds. We could use an else node, which would cost less but be slower. But let's try that. Let's see what happens if we use an else node. So we're going to sort greens out. And then... I don't think this is going to work. I think this is going to be noticeably slower than the other one. Our accuracy won't suffer. But maybe we'll save on server cost. If we have fewer nodes, maybe it'll be cheaper to run. Let's go ahead and try that and see how that works for us. In fact, let's click day and see if we get overload. Now we have overload, which is not great. We should have gone back to our old system. It doesn't save your old code, which is a little bit annoying. And this one does require 100% perfection, so... I don't know how to make this thing profitable. And we're gonna send greens up here. I could allow for some mistakes. It's not supposed to take any mistakes. But I could just sort of let some mistakes slip through and see what that does to our user base. But I think we're not going to do that. Alright, well that's accurate again, at the very least. It doesn't let us use a splitter. At least not the classical kind. I could set one of these to... I could set a thing to green and make two different nodes of this. Sort of simulate a splitter. But I don't know if that would actually improve time. Because there's not like a bottleneck here. So we're just gonna go ahead and release the code. And I think we're gonna do one more job. And then wrap this up. No, I'm sorry, I want to do the tree. The tree! Large parallel calculations. Hello, our parallelization system broke after the last Doors OS upgrade. Can you fix it? It is a very big system. Be careful. Oh, this is... Okay, so this is still baby stuff. We might do another one just to have a little bit more complicated something under our belt. So this is just splitting into two. And we, in fact, we'll copy and paste... Oh, copy and paste that bad boy. So we're doing... We split into two, now we're splitting into four. And we're running. Yep, that works. Yay, I win. Let's see if there's anything we can buy. There's no new nodes. There's some cool nodes you can get here eventually. Is there any hardware that we can get? We can decrease server cost. And we can increase socket processing by 5. Yeah, let's buy all these. Maybe that'll help us be more profitable in our business too. Currently, we're still losing money! Alright. Dictatorship. This should be fun. Greetings! It is the only state internet provider of a small country. We have a rather suboptimal code to track our people's activities. Unfortunately, we cannot allow you to change the actual code. But we have several new servers purchased on a garage sale. On a garage sale, sure. Well, they're from another country, so maybe they're not good at English. Parallel the calculations! This will help our tyranny to prosper! Yeah, I understand. I copy and paste. I get it, yes. You can choose a version of a scheme which will be used as a custom code. I don't understand this. You choose a version of the scheme which will be used as a custom code. What does that mean? So we just want to get rid of everything that's not red? We can use 5 of these. 5 things, I mean. This is obviously the slow one. We might be able to increase our speed a little bit if we split one of these into 2. And that uses all that we're allowed to use. Now, a trash can takes us over. That's a bummer. However... No, that wouldn't help us at all. All of our else's go in here. And they let it go. Get it? I should have tested that first. Oh no, will we make it? We'll make it with a bronze medal. That's just gonna have to be okay. And that is going to do it for us for this week. Thank you so much for watching. If you like this video, don't forget to hit the like and subscribe button if you're not already subscribed to the channel. We will see you guys next week with some more of While True Learn. I hope that you've enjoyed it. I already said all that stuff. Take care. Bye.